All right, I think we can start. Thanks for joining this session. My name is Etienne Caban. I work for the Food Packaging Forum, and I am responsible for this project called the Understanding Packaging Scorecard. And that is a tool that helps people in the food service industry to make the right decisions when it comes to food packaging. So, yeah, works. So as you may know, and you can see on this map here, most of the packaging of the waste that we find on our shores is due to food packaging. So all the signs here in red are related to food packaging, single-use food packaging. So the food industry really has a big role to play when it comes to curbing that waste issue. And the question is then, how do we make safe and sustainable foodware and food packaging choices? That's actually not a very trivial question. That's a very complex topic. And one of the first problems is that there is a lack of alignment on the definition of what sustainable food packaging is. The second thing, as you may know, is that when you look at packaging, usually there is a lot of certifications and labels and claims. Some are legit, some are actually dubious, and it's very hard to navigate for people in procurement teams or sourcing teams to navigate this space. And the third thing is, I guess you're also aware of this, at the moment, when you talk about sustainability, usually this focuses on the climate impact. And when you do this, you unfortunately do this at the impact of looking at other impacts that are very important as well for packaging. So we are a group of scientists. We are the single-use material decelerator. And our idea is we work with the food service industry, as you can see, with NGOs, with LCA partners, and we are brainstorming on how can we best help people that are in the decision-making process when it comes to food packaging. And our idea was to come up with a tool that's a free tool that you can access on the internet. It's open access, and it's a tool that assesses generic types of packaging. And it's a tool that makes the scientific data very much actionable for people that don't have the time and don't have the knowledge to go into the topic. So I will now show you a little bit about the tool and about the methodology behind the tool. So when we want people to look at sustainability in food packaging, as I said, we don't want them only to focus on the CO2 impact, but we want them to look at the full picture. So we designed a tool that is based on different metrics, different indicators, and we try to be as context-based as possible. So we have 3 different geographies, and we have lots of customization possibilities. And really the idea is to have a picture, the full picture of the sustainability, and not something that looks like this, which gives you a biased picture. So for us, sustainable food packaging means minimum environmental footprint, maximum circularity, and we have a third metric here, which is called avoiding the presence of harmful substances. So we think that a material packaging that is not safe cannot be considered as sustainable. And therefore, we have a specific metric that looks at the presence of chemicals of concerns into the packaging materials. So very simply, the 3 metrics that look at the environmental footprint, they are LCA based. So you know the CO2 emissions, obviously. We look also over the entire life cycle. We look at the consumption of water. And then we look at the plastic pollution. Basically, we look at how much plastic is leaking into the environment over the entire life cycle of the product. Then comes the first circularity metric, sustainable sourcing. So here the idea is very simple. We want to know how much recycled, post-consumer recycled material goes into the manufacture of a new product, or how much bio-based material you have in your product. So basically we then have a score here with a scale. If your product is reusable, then that means you do not need any new material, so it gets the best score. And if you have a material that doesn't contain recycled content, or bio-based content, then you get the worst score. The other metric for circularity is called recoverability. So here, very simple, we look at the potential of the material at the end of life, the potential to be recycled, composted, or reused, or if it ends up in the environment to biodegrade on itself. And here what's very important is that we want to insist on the recyclable versus recycled problem. So for instance, we look at whether the material, the product is actually designed for recovery, but we also look at whether the user has access to the infrastructures, the facilities, to actually recycle or compost or reuse the product. So it goes together for us. So same thing, we have then a score based on this scale here. If your product is absolutely not recoverable, meaning not compostable, not recyclable, or not reusable, then you get the worst score. And on the opposite, if your product is fully recoverable, meaning reusable, then you get the best score. And then I will talk now about the last metric, the chemicals of concern metric. I will spend a bit more time on this because I think that's usually a topic that is less known from my audiences. So the idea here is that we have about 16,000 food contact chemicals that are known into different materials. You know many of them. I think some made the headlines recently, for instance, bisphenol A or phthalates or PFAS. And some experts consider that there are actually up to 100,000 of these chemicals. You can access the database from the Food Packaging Forum on this. And this list is based on industry inventories and on regulatory lists. So that's the first fact, about 16,000 food contact chemicals. And then the problem is that these chemicals can actually migrate. And we have strong evidence for at least 2,000 of them that can migrate from the packaging into the food. Again, we have a database here that sums up all these chemicals that have been shown to actually migrate. Another fact is we detected about 10,000 of these chemicals into our bodies. This is from different biomonitoring programs and cohort studies in the EU. Recently, there was one made on MEPs from Brussels. They have all been tested with PFAS in their blood. So we all have parts of these chemicals. I'm not saying that they all come from food packaging, because it's very difficult to make the distinction in the full exposome. Where does these chemicals come from? But a lot of them are used into food packaging. And we are working on, this is work in progress database looking at this. And finally, the last fact is that we know that many of these chemicals, unfortunately, are hazardous, and they pose a risk for the human health. So we have different papers here that you can look at. Some of these compounds are reprotoxic, carcinogenic, or endocrine disruptors. You know all the story. Again, we are currently listing them in order to provide this information on the Food Packaging Forum. So, therefore, in order to take into account the problem of the chemicals, we build up a metric that looks at the presence of the chemicals. So we made a list of priority compounds that should be taken out of the different packaging materials, about 600 compounds that we consider are highly toxic and should be removed. Then we look at the inertness of the packaging material. So some materials are actually quite porous and prone to transfer of chemicals. This is the case of plastics, and this is the case of paper-based materials. On the opposite, some materials like glass and metal are relatively inert, and they do not let the molecules transfer from the packaging into the food. And finally, we look at the food and material interaction. So it turns out that there are a set of parameters that influence the migration. This is the temperature, the duration of storage. The size of the container is actually also important because of the ratio in between the surface and the volume. And finally, certain foods like fatty foods and acidic foods actually speed up the transfer of the chemicals into the foodstuff. So now I've given you the very basics for the methodology of this tool, and I will show you how to use it. So the first thing you do is to assess and compare generic types of food packaging. We have two modes of utilization. I will only show you briefly the product comparison mode. As I said, we have 3 geographies at the moment. We have 13 use cases with about 100 generic types of food packaging, so for beverages and for food. And we have a lot of customization options as well. So now I will try to show you this live. All right, so this is the interface of the tool. I'm only showing you today the very basic utilization, so comparison of products. The first thing you're asked is to select a geography. So I will pick Europe for the demo today, and then you click on compare products. And this is the different types of products you can select, the different use cases. So let's go, for instance, for a cold cup here. You are then asked to tell if you know which type of food goes into the container that's related to the chemicals of concern score. So let's say it contains a soda. You select the food, and then you reach a page where you have a list of different products that you can that you can select to compare. As you can see, we have reusable options that are clicked already, and you cannot actually generate a score if you do not select one of these, because the idea is that we want the user not only to look at materials, compare materials, but also to compare systems. So you have to select at least one reusable option to go further, and then you have all the single-use options. For the sake of the demo, I will just pick them all, and then you go to compare, and you reach the result screen. So this is a sort of color-coded result table. On the left, you see all the materials, all the products, that you've selected. And these are the reusable, and then you have the single-use options. And then you see the 6 metrics that I've mentioned before. So the 3 first metrics looking at the environmental footprint, then the 2 circularity metrics, then the chemicals of concern metrics looking at the harmful substances, and then you have a summary score. So basically, what you see here is that you have a lot of trade-offs. So you have some materials that are actually very good at the environmental footprint, but not as good in terms of circularity, or really not good in terms of chemicals of concern. So that's how you can have a very first overview and use of the tool. And I just want to show you, you can also customize a lot of things in this tool. So for instance, we have by default a certain number of reuse. Here it's 40 times for a polypropylene cup. And if you're not happy with this, you can actually customize. And you can change the number of reuse. So if I put here, I don't know, let's say 200, maybe that's way too much for a plastic container, but you see that the scores are actually changing live here. So I can put it back to 40. And you see the scores are changing. You can adjust the transportation mode and the transportation distance. You can also specify whether you have access to recycling facilities. So you have to toggle this on in that case. And then you can have a better score in terms of recoverability. For the bio-based, you have a sourcing certification possibility here. And then if you know anything about the presence of chemicals of concern in your material, then you can also say it. So let's say you are sure that you don't have any of the 600 priority chemicals. You can check it here. And then if you have a third-party verification, even better, you can select it here and you can recalculate, and you should see that the score has changed. So this is your new modified PP cup, and you see that it has a much better score, for instance, than the original that is here. So that was the very very fast presentation of the tool, the live tool. And back to the presentation. The second thing you can do once you have done this comparison is to actually start analyzing the data and working on a plan to transition, maybe for reusable, for instance. So here I've picked another example just to show you the trade-offs again. This is the cold case use. You have here a reusable glass takeout with a plastic lid, and then you have 4 different single-use options. So this is the result table, and if you do a sort of deep dive into the results here, And if you only look at the carbon impact, then it's obvious that the paper has a very good score. Glass, the reusable glass with 40 uses is not so bad in terms of you have the absolute value here. And you see that the aluminum option, the single-use aluminum, is very bad, and that's due to the all the energy you need to actually process aluminum. So that's for the carbon impact. In that case, the paper option, single-use, is the best. If you look at the water usage, again, paper scores very well. This time the PLA is the worst case. That's due to all the water that you need for the crops in order to actually produce the building blocks for polylactic acid. And you see that the glass reusable one is doing okay. Of course, you need a lot of water for the washing cycles for the reusable ones. But now, if you look at the all 6 metrics together from our tool, then you will see that this time the glass reusable scores best. And the reason is it has a very good circularity score and also a very good chemicals of concern score. And this time the worst is the recycled PET, and the paper is only on the second place. So just to show you that this can tell you when actually reuse, in which context it can be the best option. Another very important question for reusables is plastic a good option for scaling up reuse systems? So as I said before, some of the materials are not inert actually, and they can leach out a lot of chemicals. And it turns out that most of the chemicals that are listed as food contact chemicals come from printing inks, then from plastic, and then the third category is paper and board. So there are lots of chemicals into plastic that can actually migrate. It's a very complex, chemically complex material, and I invite you to have a look at this report here from the Plaschem projects. It's really interesting if you want to know more about the chemicals in plastic. If you focus here a little bit on some plastics that are very often used into the reusables, you see here polypropylene, polyamide, polycarbonate, and melamine resin. They have all been shown to contain a lot of food contact chemicals that can actually migrate. And this is basically a list, a very simplified list of the types of chemicals that you can find into these materials here, into these different polymers or plastics. So you see that you find a lot of chemicals that are hazardous, like bisphenol A, phthalates, etc., or melamine or formaldehyde. And it's not only that those plastics have those chemicals, but there are some very specific things that happen with the reuse systems, unfortunately, when you use plastic. The first one is a question of stability. So as you can imagine, basically all the plastics are going to age with the subsequent reuse cycles, and you can have a degradation of the polymer itself, which is going in turn to lead to more migration of chemicals. So this has been shown in many different scientific papers. I encourage you to look at the last one in particular, very much focusing on this. And I'm sure you've all seen this kind of effect. If a molecule can actually migrate out of the plastic into the food, the opposite is also true. So you can actually pick up molecules and chemicals can migrate inside the plastic. I'm sure you've all seen this kind of effects with tomato sauce, for instance, on a plastic container. And the problem is that these containers in plastic can also take up detergents that are used during washing cycles. Are the testing requirements sufficient? The answer, in our opinion, is not. So when you test the migration from plastic material in the EU, you are only required to do 3 cycles. But many of these papers show that actually there is a drop in the release in the first 3 cycles. A lot of chemicals are leaching out, and then there is a plateau. But unfortunately, with the polymer aging, you will most of the time observe that the curve goes up, and there are more and more contaminants and chemicals that are actually starting to leach again from plastic. So here it's a case where the regulators do not really have this under control because of these only 3 cycles. And finally, I was able to discuss a lot with different companies doing washing, logistics, and washings for reusables. And I think it's pretty clear among all professionals that, of course, you usually need a little bit more energy to dry out the plastics when compared to other materials like glass and metal. and therefore you increase a little bit the environmental impact by doing so. I know that it's sometimes a rather unpopular presentation, especially for people using plastic, and I know that from my impression, a lot of companies here are already using plastics for reusables or will use plastics for reusable. These are a set of recommendations. If you cannot do something else, then non-permanent material. If you cannot use glass or metal, you should communicate to the users that this should not be used for microwaving. So no high temperatures, that will increase the migration. Reduce the storage time is also a good option to reduce the leaching of chemicals. Use larger portions, so larger volumes when compared to the surface ratio. And of course, that's maybe the most difficult, but if you avoid fatty foods and acidic foods, then you will also decrease the migration. Applying the results at the end, so I'm just showing you a few of the people we're working with. I use the tool a lot to communicate and educate about the challenges of sustainable food packaging. I'm working with Mission Zero Academy, for instance, like Train the Trainer. I'm teaching them the basics to use the tool so that they can actually apply their certifications on restaurants. We are working with NGOs. Last year I was invited by New Era to talk to their members about this very specific issue of chemicals in the plastic reusables. It's very interesting because actually there is a lot of concerns at the moment, and some manufacturers of plastics are starting to come to us, and they really want us to look at their products and to look at the chemicals of concerns together with us. I cannot tell you who they are because we are under NDA, but I see it as a very positive sign because maybe there are options and chemicals that are less problematic to be used for plastic manufacturing. Driving change here, I just wanted to let you know that we work with some of the biggest food service industries, and they regularly tell us that there is currently a change in the consumer mind. So many of the consumers are really concerned about this problem of chemicals. And I would say watch this space, because in the future, I think this is really going to become the next thing after CO2 impact, in our opinion. So with this, I'm finishing, and there will be lots of time for questions. I hope I could show you that this tool, it's a free access, it's a free tool, online tool, is really important to have a holistic tool to actually characterize the sustainability of food packaging and to help people in their decision-making process. The chemical safety is extremely important. This is part of sustainability and should really be into all assessments of the impacts. If you can, in the different reuse business for food, it's better to actually focus on inert and permanent materials like glass and metal in order to avoid issues with chemical safety. And we welcome discussions and, of course, exchange of data. I was discussing again with the washing companies to get data to refine our model, for instance, for the reusable, the energy and the water consumed during the cycles. We are really open to discussions and to have more data to refine our tool. And please engage with us, and I can connect you also with experts from the SUMD group if you're interested, the single-use material decelerator. And let me know now if you have any question.
Thank you. Just a question. When you calculate an overall score for a packaging, how do you weight the different aspects? Because that's a very often asked question. Can you give me one score? What is best? And the reality is you have to look at each component separately, and probably the weight you give to each of it is different based on your application.
We don't weight them. It's just a normal average of the 6 different scores. And we do this exactly as you said, because we want people to look at all impacts. But of course, you're welcome to use the tool and to pick the one you like. I mean, sometimes the the companies, they do have objectives for CO2 only, and they're happy to look only at the CO2 impact. But we recommend to look at all 6 metrics.
Yeah. Thank you.
For the calculation of reusable containers, how do you measure the CO2 of the collection, or like transportation, or the water usage? Because I think it varies, depends on what kind of transportation you use. Or
Yes, absolutely. So we have, I don't know if I can show you again. All our data is coming for the LCA part is coming from EcoInvent, and of course, yes, I don't see my. Okay. And you have the opportunity to actually change the. Sorry, I wanted to show you, but I don't see my. Here it is. You can actually change the transportation here, and we give you the opportunity to change the type of transportation, for instance, of a vehicle you use, and then you can also adjust here the kilometers here, and you can add a second transport stage. And right now, we are trying to refine our reuse model in order to add the opportunity to have this backhaul transport or this collecting thing and to add it to the model. Yes.
How about water usage?
So this is embedded again into the. I don't know if you. So you can access the full methodology. We are transparent about our methodology and our data. This is all explained there. This is sort of activities. So for instance, extrusion of polymer is one activity, and all the data comes from the EcoInvent. So that gives you the water usage and for instance, the CO2 emissions for this specific activity. And then we collect all activities to make one product into one big thing. That's how we account for the different things.
Thank you so much.